I'm Anil Kumar, and with the help of this video, we'll try to understand how to find x-intercepts for a quadratic function and how do they change when the quadratic function is transformed. So the question here is, if f of x is equal to minus 3 times x plus 5 whole square plus 48, determine x-intercepts for each function. So we have four different functions. The first one is the original function, and B, C, D are transformed functions. So let us first find the x-intercepts of the original function. Well, I've seen some students struggling at this stage to find x-intercepts when the function is given in vertex form. So let me write here f of x as 0, since at x-intercept y value is 0. So we will solve the equation 0 equals to minus 3 x plus 5 whole square plus 48, right? So I'd like you to follow these steps carefully so that you always get them right. So first step is take 48 to the left side, so it becomes minus 48 equals to minus 3 times x plus 5 whole square. Now divide by minus 3. So we get minus 48 divided by minus 3 equals to x plus 5 whole square. Minus 48 divided by minus 3 is 16, right? So it is 16 equals to x plus 5 whole square. Now we can square root both sides. That will give us square root of 16. But whenever you square root, do plus and minus. So that could be a mistake at times, right? X plus 5. So we are looking for two solutions. And we know square root of 16 is 4. So we are looking for plus and minus 4. So let me write this equation as x plus 5 equals to either plus 4 or minus 4. Is that okay? So we are looking for two separate solutions. That gives us x value as equals to, if I consider, minus 4. If I consider plus 4, then my equation will be plus 4 minus 5, and that gives me the answer as minus 1. And if I consider minus 4, then minus 4 minus 5 gives me x value of minus 9, right? So I have two x-intercepts in this particular situation. One is at minus 1, the other one is at minus 9, right? So part A, we can say the x-intercepts are at minus 1 and 0. The y value is 0, right? The other one is at minus 9, 0. You get the idea. So that is how we should be finding x-intercept when the equation is given in vertex form. I hope that point is absolutely clear. Now, let's look into the other parts. You don't have to find a new function and do all this calculation to find the x-intercept. We can see transformation of these points and get the answer. So let us say if for f of x, a and b is the point, then its image on transformed function will be what? For b, it is minus half, that is the vertical value, which gets multiplied by minus half. There is no transformation along the horizontal side, so a value remains same. So here the transform point should be a, and the y value will change, it will become minus half of b, right? So let's find the new coordinate points for these x-intercepts. So if I multiply by minus half the y values, which are 0, they remain 0, correct? Therefore, my x-intercepts here will still be at minus 1, right? And at minus 9. You get this idea, right? So that is how it is going to be for part B. Now let's look into part C. What really happens here? Now this equation should be rewritten to really understand what is going on here. So let me write this as y equals to f of. So we have minus half. So let me write this as minus half, and within brackets we have x plus 2. You get the idea, right? This is the equation. If that is the equation, then how will x and y coordinate points change? As far as y is concerned, there is no change. For x, so I can write the coordinate points as b for same value. For y, for x, they get multiplied by minus 2, so we get minus 2 times the original value of a, and plus 2 means moving left by 2 units, that means minus 2 again. So that gives me the x coordinate point. Let's do our calculations and write down the answer. If a is minus 1, then minus 1 times minus 2 is plus 2. Plus 2 minus 2 is 0, right? So let me write down the calculation, then the answer. So we'll do this as minus 2 times minus 1 minus 2. So that is the x value. Y value is 0. That is the x-intercept, right? That's for the first point. For the second point, we have minus 9 times minus 2. Well, either way you could multiply. Minus 2. So that is the x value, and the y value will be 0. It is an x-intercept, right? Let's calculate. Minus 2 times minus 2 is plus 2. That means 0. So it comes at origin itself. The other point here will be at 9 times 2 is 18 with plus, and you get minus 2 gives us 16. So the other intercept is at 16, 0. I hope you understand now, right? Now let's do this one. Here again, you should rewrite. If you don't, you may do a mistake. And let me show you how. This equation should be written as 3 times f of, take minus common, then you get x minus 2 in the bracket. Do you see that? Now you know exactly how the transformation is taking place. If a and b are on the original function, their image will be at point A. The x value gets reflected on y-axis and then moves 2 units to the right. So the a value will be minus a plus 2. Do you see that? The y value will be multiplied by 3. So 3 times b. So these are the new coordinate points. So now using this transformation on the original points, we get our answer. Minus of minus 1 is 1 and 1 plus 2 is 3. So I'm directly writing the answer. Anything times 0 is 0. So that remains. The other one, minus of 9 times minus is 9 plus 2 is 11. So we get 11, 0. So these are the new sets of x-intercepts on our transform points. I'd like you to go through this video once again, understand the concept, since similar questions are always there in the test paper. I hope you appreciate it. I'm Anil Kumar. You can subscribe to my videos and learn a lot. Thank you and all the best.